lunar surface has some of the most extreme temperatures in the entire solar system. It can get so hot at the equator at noon that liquid water would boil instantly. That same location can get so cold at night that liquid oxygen would be stable. But the most extreme places on the moon are at the North and South Pole, where permanently shadowed regions get so cold that they're the coldest place we've ever measured in the solar system. The reason for the moon's extreme temperatures is because of its axial tilt. Now, you all know that the Earth is tilted by about 23.5 degrees, but the moon is only tilted by about 1.5 degrees, meaning that a crater near the poles that has walls that are higher than about 1.5 degrees above the horizon will shadow its interior, making those environments really cold. When measuring extreme cold, scientists use Kelvin. The Kelvin is a unit of temperature. Unlike Celsius or Fahrenheit, Kelvin has no negative values, because 0 Kelvin equals absolute zero, the temperatures at which molecules cease to vibrate. Any colder than that, and you wouldn't produce heat at all. For comparison, the boiling point of water is 373 degrees Kelvin, and the freezing point of water is still 273 degrees Kelvin. That means absolute zero is really cold. Scientists have long theorized that in extremely cold, permanently shadowed regions near the lunar poles, water could become cold-trapped or frozen within the soil, leading to the accumulation of vast reservoirs of ice over billions of years. In 2009, the Lunar Crater Observation and Sensing Satellite, or LCROSS, impacted the floor of Cabeus crater and released a significant amount of water ice. It's unclear where this ice came from, or how much of it exists outside of Cabeus, but the data suggests that polar ice deposits are extensive enough that they may be potentially a valuable resource. Diviner is the first instrument to measure temperatures inside permanently shadowed regions of the moon. It is one of 7 instruments aboard NASA's Lunar Reconnaissance Orbiter. Diviner measures the amount of emitted infrared radiation and reflected solar radiation, and it is from these measurements that scientists are able to determine the moon's temperatures. The Lunar Explorer Neutron Detector is another instrument aboard NASA's Lunar Reconnaissance Orbiter. It measures the flux of neutrons from the moon's surface, which can be used to infer the presence of water. Neutrons are produced when cosmic rays break down the atoms in the lunar soil, sending high-energy particles back out into space. Some of these particles are high-energy neutrons, which are slowed down and absorbed by elements in the lunar soil, in particular hydrogen. As hydrogen is a key component of water, slow neutrons are indicative of the presence of water ice near the surface. Your mission is to use the data provided from these instruments to decide on the best location for a lunar base. You will be provided with maps of the Lunar South Pole. Locating your base near the poles can leave you close to water ice and other resources, but can also mean that it is very cold and very dark. You might also need to be able to see the Earth so that you can make observations or radio home for help. With the maps provided, you should pick out the location that you think would make the best home for the first ever lunar base. But remember, there's only enough money to build one, so you need to provide good reasons for the location you choose.